In this video, we're going to look at the area of a sector of a circle. So let's first figure out what is a sector of a circle. So if I have a circle here, and I were to take, here's the center, that looks about the center. And here's the radius, and from here over is theta. A sector of the circle is just the area of that part right there. Okay, so basically it's kind of like a piece of the pie or something like that. You're taking your circle and you're just chopping out one chunk of it, but you do have to go through, you do have to have the center, so that point there has to be on the center. Okay, so we want to figure out, well, what is that area? And so let's go through the same logic we used to find the arc length of a circle to look at the area of a sector of the circle. And so we first start off with what is the area of a full circle? It is the area of a full circle. And this is easy enough. This is from geometry. Area is pi r squared. Now we don't have a full circle, we only have a part or a fraction of the circle. So we're going to multiply this by a fraction of the circle. Multiply by a fraction of the circle. And so our fraction from before, well, we said, well, we have some angle theta, and, well, one revolution is 2 pi radians. So again, it's going to be theta over 2 pi. So this means our area, which is going to be the fraction times the area, is going to be theta over 2 pi times pi r squared. All right, now unlike the arc length where the 2 pi's cancel out, this one only the pi's cancel out. So there's a pi, there's a pi. And so we end up with theta r squared over 2. And normally what we write is 1/2 r squared theta. And so there is our formula for the area of a sector. So the area of a sector is 1/2 r squared theta. Put a box around that. And again, I'm going to stress this. This is in radians. Put a box around the word radians. So you got to make sure you're in radian measure. So let's look at an example. A sprinkler on a golf course is set to spray water over a distance of 75 feet and rotates through an angle of 135 degrees. Find the area of the fairway watered by the sprinkler. All right, that's a good question. So we have the sprinkler. I'll draw this. 75 feet. And it rotates whole angle of 135 degrees. Just imagine that this is part of a circle. So this thing is going back and forth and watering that fairway, I guess is what it is. And so we want to know how much area is being watered. So that's a good thing to know, because then you can start calculating how much water you're putting in per square inch and things like that. And so you do need to know the area. And so area is 1/2 r squared theta. And so let's see, that's 1/2 r is 75 feet squared, and theta is 135 degrees. Of course, that's in degrees, so we come back here and realize, ooh, we gotta be in radians, so we do have to do a conversion. Luckily, to convert from degrees to radians, we multiply by pi over 180, and there we have it. And so this, of course, is a word problem, so on word problems, we do stick it in a calculator and get a decimal equivalent. So let's see, 0.5 times 75 squared times 135 times pi divided by 180. Let's see if that comes out right. It does. So it's 6,626.80 feet squared. So that is how much area that one sprinkler is getting to. All right, so again, in this video, we came up with the area of a sector. This little logical derivation we did is actually quite helpful. It's kind of hard to remember this one. And so if any time you need it, you just think, well, I got pi r squared, and I'm multiplying it by some fraction, which is theta over 2 pi, and you can quickly get that area of a sector. And then we looked at an example of using that formula.